Welcome back to Knowledge Academy's YouTube channel. In Part 1, we explored the concept of conditional probability and how it's used in machine learning. Now, it's time for some hands-on action. Today, we're going to implement a spam email classifier using the Naïve Bayes algorithm in Python. We'll see conditional probability in action and build a model that can predict whether an email is spam or not. Make sure to watch till the end for key takeaways, and if you haven't watched Part 1, check it out first for the theory behind conditional probability. First, we need to import the necessary libraries. So, for this we will need to import NumPy, pandas library, along with count vectorizer from sklearn feature extraction text. Next, we will import train test from sklearn model selection. Then import multinomial NB from sklearn Naïve Bayes. Then next import accuracy score from sklearn metrics. Now we will load the dataset. For this tutorial, we'll use a simple spam dataset where emails are labeled as spam or ham. Here ham represents not spam. Let's create a small dataset for this. This dataset contains short email messages and their corresponding labels. Since Naïve Bayes works with numbers, we need to convert text into a numerical format. We'll use count vectorizer to convert words into a frequency-based numerical representation. So for this, we will write vectorizer equal to count vectorizer, then close parenthesis. This is done to create an instance of count vectorizer. Now we write x equal to vectorizer fit transform, then in parenthesis df with the column name message. Now this is done for x to stores the emails in a special format where each email is represented by numbers instead of words. This numerical data can then be used to train the Naïve Bayes model to recognize patterns and classify emails as spam or not spam. Then in the end of this step, we will write y equal to df, then in close bracket label. This extracts the labels from the dataset and stores them in the variable y. Now, let's split our dataset into training and testing sets. We will split x and y in training and testing dataset using train test split. Then in bracket we write x, y, then test size equal to 0.3 and set random state to 42. Here, the test size equal to 0.3 means 30% of the dataset is used for testing and 70% for training. And random state equal to 42 ensures that every time we run the code, the data is split the same way. If we remove random state, the split will be random every time. Now we'll use multinomial Naïve Bayes, which is ideal for text classification problems. For this we will train the Naïve Bayes model. We write this as model equal to multinomial NB, then a closed parenthesis. This creates a Naïve Bayes classifier. Now to train the model we will write model.fit, then in parenthesis xtrain and ytrain. Then run it. Our model is now trained, but how well does it perform? Let's check that as well. For this, we will make predictions and evaluate the model. This can be done by using model.predict, then in parenthesis xtrain. This is used to do prediction on test data. Now to calculate the accuracy, we will use accuracy score on ytest and yprep, and then print the accuracy using function as shown. Now for small data you may get accuracy 100%, but in real-world large data, this accuracy comes down. Now in the last step, let's test the model with new messages. Here we will give some new messages, and then we will convert the text to numeric data using vectorized transform. Now we will make the prediction using model.predict on the transformed message data. Then to print the prediction, we loop through each message and its prediction. If prediction is equal to 1, then message is spam. But if prediction is equal to 0, then message is not spam. This result is then printed in a readable format as shown. Try running this with different messages to see how the model responds. So, here we used conditional probability in the Naïve Bayes classifier to predict spam emails. Naïve Bayes is a powerful and efficient algorithm for text classification problems. And conditional probability allows the model to adjust predictions based on existing information. And that's it for today's tutorial. If you found this helpful, hit the like button and subscribe for more machine learning content. See you in the next video.